My name is John Platais. I own enterprise capacity and business intelligence for the largest fintech company in the world. And as part of that role, it's my responsibility to ensure that we are able to predict problems before they occur. And so we employ multiple different business intelligence tools and initiatives in order to do that. And one of the things I'm going to talk about today is text mining, which realistically, in the great scheme of, they're going to hate me because I move around. Realistically, in the big scheme of data mining, text mining is probably one of the newer, less mature, yet futuristically exciting opportunities that come in the form of analyzing large amounts of data to draw conclusions. So, go ahead. This is just a little bit about me. I don't expect anybody to care, but one thing that I do want to add is that one of the interesting things about me and every person in this room is odds are you have evolved over time from where you were to where you are now. Okay? In a prior life, I was a history teacher, and I taught middle school social studies. Doesn't seem to have anything to do with business intelligence for a large banking conglomerate. Okay? Beyond that, I was an elementary and middle school principal. Again, nothing to do with data mining for a large business conglomerate. The reality is that they have a lot to do with large business conglomerates, and the fact that I use data in those occupations just like I use data now. It's just my sources are different, but my methods are the same. I did a next one. So what we're going to do is we're going to talk a little bit about data science. And when I've talked about this before, people come to a HackerCon and you expect me to say things like 128-bit encryption. Okay, because there I said it. It has to be incorporated somewhere in there. Okay? And people instantly think, well, all right, yeah, crunching a lot of numbers, that's really awesome. But, I'm here to learn about 128-bit encryption and how it can be reseeded to a secondary site in order to enhance that so that nobody can hack my Facebook account. And that's cool. But most of us don't have a whole lot of usage for trying to decrypt 128-bit encryption, 512-bit encryption, 1024, take your pick. Most of us live in the real world where you have to meet deadlines, you have to provide data to those who ask in far less time than you really need to do it. You've had it, Friday night, it's 4:53, and the guy calls you up and says, well, I would like to know how many vulnerabilities we've detected in data center ABC during normal business hours, and I want to ensure that we are providing optimal performance for any international trade coming from Singapore. And I need it in 6 minutes. So we're all data scientists in some form or another, because we get asked those questions all the time. So part of this is to make sure that we convey and share a common understanding, and that is that we all have to be data scientists as information security professionals. Why do we have to be data scientists? Because opinions suck. Opinions only exist because there's really no data. Okay? Give me data or give me null. I had to throw that out there. I'm sorry, that's bad, but it's cool. And then without data, without me tripping over the cord, you're just another person with opinion. So ultimately, as we go into this, and as you as information security professionals, and as myself as a data scientist proceed, we need to make sure that we not only use data in making intelligent decisions, but use it well and use it responsibly. As security professionals, as a data scientist for a banking organization, we have the ability to stop business. We do. Or alter it, or adjust it, and we need to do so intelligently, ethically, and responsibly. So, I had to put this up there because part of my ethical responsibility when I share about data scientists and data science is to ensure that you understand that there is a framework and a methodology that goes with it. And I'll get into the cool stuff in a moment, but this is kind of like science in 7th grade, where this lady gets up in front and says, well, it all can't be fun. Okay, well, here's the potentially not so fun part. But it's something that everybody needs to get, that when you do data mining, and I always like to say that using data, manipulating data, data mining is the ultimate hack. It really is. Because data will shift the direction of any organization. It will. I do it all the time. So, again, ethically, responsibly, intelligently, we need to do that. And in order to do that, we need a proper framework so that we can ensure that we've done it correctly. So if you're not familiar with it, and just because I intend to bore you for a few minutes about proper data mining technique, if you're not familiar with it, the CRISP-DM model exists as the quintessential data mining operation and framework. Why? Well, because there just isn't another one. Maybe someday there will be a better one, but right now, that's what we've got. And basically, it's okay. It says, look, in order for you to be able to do what you have to do, to ensure that John does not send the banking industry down the wrong path, he has to follow a certain pathway to the correct information. And that pathway includes these pieces. So I'm going to say them so that at least I can say at the end of the day that you all heard them. And the first one is you have to understand what the business needs. And we will get to what text mining looks like in a moment, but it all ties in to the CRISP-DM model and the ability to draw appropriate conclusions. You have to understand what you need to know. If you've ever gotten the call at 4:53 on Friday night from your CIO saying, I need to know this and I need to know it in 5 minutes, don't ever let him off the phone until you understand what he actually needs to know. Because we know how it works. You're going to send it to him, he's going to send it back, go, no, that's not what I wanted. Try again. You have to understand what data you have to work with. You have to prepare your data. Let's be realistic. Most data is garbage. It just is. I see people nodding in the audience. You've been the victims of bad data. Okay? You've been reamed out because of bad data. Most data is bad, and nobody should ever be at the receiving end of a bad experience because of bad data. Because you know what? That's just sloppy. So being able to use good data and use it well is important. Once you've done all that, that accounts for 99% of all that you do as a data scientist and as an information security professional using data to draw conclusions. If you talk to the chief data scientist for American Express, they built one of the largest business intelligence data warehouses that I've ever seen. It took them 5 years. 5 years. Who gets 5 years to work on anything? 5 years is what it took, and 70% of that 5 years was cleaning the data. And then ultimately, once you've had that, it's all ready, then you can build your models, and then you can do the cool stuff. Okay, well, I'm going to cheat. I'm going to skip to the cool stuff. Okay, but it's only because I want to show you how easy text mining can be. Okay, so before I show you how simple mining text is, and we're going to I picked 3 Trump speeches to mine and see what words he uses the most frequently. You'll notice that it's probably not a shock. And you know what? Before I do any of that, whatever political viewpoints you have, I don't care. Okay? So, having said that, let's think about text mining for a moment. You know what? Statistical analysis has been around forever. People have used numbers. I mean, Mark Twain, there's lies, there's white lies, and there's statistics, right? Okay? So anytime somebody adds numbers to a lie, it gets credibility. Isn't it cool? All you gotta do is put some numbers to it and people will buy it. And they don't even have to be bad numbers. They're real. You just pick the ones that support your case and they don't really represent anything, but you use them because, hey, that works. So let's think about text mining. Let me kind of explain what it is. And you probably got the idea, but imagine for a moment you're back in college, right? You went to history class. They made you read a lot of boring stuff and write papers on it. Am I just like, is this just me? How many of you had that experience? Okay. I was a history teacher. I actually liked that stuff. But ultimately, you would go through and you'd go to the library and you'd bring home this stack of books because you're not really going to read them. You're going to scan them for random things that work for what you want, and then you're going to cite them in the end. People do it. Okay, now the computer will do it for us. It's totally awesome. Boy, I would have gotten a lot better grades in college if I had this. Okay, so think about text mining. It's basically being able to use a computer program to scan through large amounts of text and identify anomalies, similarities, and trends. So let's think about how cool that could be in a corporate environment. What if you could scan every email stored on your corporate email servers to identify the general sentiment of your employees? Who really tells their boss they're pissed? Okay? I mean, you may tell your boss, but your boss's boss, your boss's boss's boss, everything's great, man. Okay, everything's wonderful. You want that in 6 hours? Sure. Okay? You can never tell. Imagine if you could have a computer tell you how happy people really are by going through all their email. What about internal information that shouldn't be shared? What if you could scan 5 million emails for a particular sequence of words and identify the person who sent it? What if you could compare the text of one document to a known document from the same author to evaluate if they really wrote it? Law enforcement, ransom note, suicide note. Did this person really write it? Validating signed documents from famous people worth thousands and hundreds of thousands of dollars. Okay? All of a sudden, we have the ability to do that, not only automated, but in mass, in seconds. Okay? It's not particularly complex, nor is it particularly like at the end of it you go, oh, that was cool. But it's powerful and it can do a lot in a very short amount of time. Okay, just because I'm going to ramble. Let's think about what we can use it for. All right, and we already started going down this. So again, text mining, the ability to take a look at a lot of information, a lot of text, and draw conclusions from it. Okay, so let's just think about it. Speeches. Speech archives, and that's cool. Back to history class in college. You can certainly do that. Tweets. What if you could track the tweets of your employees? That's just scary. But it can be done. It can be done very easily and be done in mass. When I first started this project, and I was talking to Mr. Goetzman, who runs this conference, I said to him, hey, wouldn't it be cool? Anybody who follows CypherCon, I'll just mine their tweets and find out all about them. Then I thought, oh, I'm going to have to come talk to these people. I don't know if I want to know that much about you. The lady up front is laughing. Facebook. In law enforcement, we have two people that are part of this project and really part of everything that I've done for CypherCon for a couple of years are these two people right here, and they're involved in law enforcement. Okay? Facebook. It's amazing how many people commit crimes and tell the whole world on Facebook. The problem is nobody ever thinks you'll find it. Okay? Text mining in minutes, by geographic location, by certain key sequence. And anybody who wants to brag about stealing a car, carjacking, pick a term, we'll find it. Books, articles, personal correspondence, instant messaging, email, web pages, medical records. I mean, that's a cool one. Go through 50 million medical records looking for trends and diagnoses over time to identify which things your company should insure and which things they should not. Ethically, I think that's a horrible idea because I think they should insure everything. But we know they don't. Phishing analysis, junk mail. You ever wonder why you get certain junk mail and other people don't? You can find out. Analyze the type of junk mail that people get over time and correlate them to sociodemographic, gender, and so on, and you'll find out why certain people get junk mail that other people don't. That's cool. All right, next. Okay, so having said all that, how do you do it? I'm going to let you in on a secret that most people don't like to share. You ever have somebody that you work with that knows how to do one thing and they won't tell you how to do it? I had one person I worked with once. They ran an Access database, and, that's just silly when I say it now because who the heck does that? Okay. They ran an Access database, and they had a naming convention for all the corporate customers that annually spent more than $100,000 a year. They would not tell anyone how they tagged those people. That woman survived layoff after layoff because she held the secret to data and information. So, I'm going to go ahead and tell you how easy this is because it's going to help you with your job and make me look far less impressive. Okay? Because ultimately, being able to do everything we just talked about is relatively simple and can be done via free tools that you can access when you go home tonight or tomorrow, depending on how much you've had to drink tonight. So, to give you a bit of a guideline on this, Rapidminer up here is my personal favorite when it comes to free data mining tools. If you're not sure what that is, if you've ever taken statistics in college and somebody made you buy a program called SPSS or PPSP if you're really an open source fanatic, because that's the open source version of it, okay? You realize that it was a glorified version of Excel that had behind it a statistical engine. Rapidminer takes it and builds it into a graphical interface that most people can use. If you're glutton for punishment, you could learn R programming. I am an R programmer. It's 50 times faster. It's far more robust. But it definitely makes you want to drink when you try and figure out the syntax. Okay? But hey, if you're up for it, go for it. So what we're going to demonstrate in a few minutes is how simple it is to build a data mining project using Rapidminer and a series of documents. And again, my goal here is for you to leave going, that's it? Because it's a relatively simple process. Before we start, I'm going to give you kind of a look at what the end result looks like because I only have about 6 minutes left. Basically, Rapidminer uses a series of modules that you piece together and you tell it, hey, this is what I want to do. In this case, I've selected 3 documents to the left-hand side. I've built an embedded process in the middle that includes within it the ability to tokenize the document and then output that document in multiple formats, including a visual screen that you see on the screen as well as Excel, which I still, unfortunately, like to use to crunch data because the truth is it's really good at it. what I did is I took 3 speeches presented by our President Donald Trump. Again, your political preference, I don't care. Okay? And one of them is his inaugural speech. One of them is his acceptance speech for the Republican Party. And the other one is his immigration reform. And if you look at the tokens, and I'll explain what a token is in a moment, the tokens across these speeches, you're not shocked. I don't expect you to go, oh, wow, I never thought that would come along. Okay? Okay. Number one, the number one most used term or group of terms in all of his speeches is Trump. He likes him, which is good. Everyone should like themselves. Okay? The second, or one of the other top ones is Clinton. Yeah, she doesn't like her. And if you keep going down, most of it is relatively patriotic. The term Donald appears at the top. The term Donald Trump appears at the top. Ultimately, Donald really likes to talk about Donald. And which, you know what, I guess the truth is that's kind of his job, isn't it? Now imagine if you could take that same analysis, multiple emails, multiple documents, multiple sources of any kind. I did this before today with Bram Stoker's Dracula. Just threw Dracula in it and said, hey, what are the reoccurring themes in Dracula? That's not a pleasant book. There's 2 key things that you can do with text mining that will allow you to draw conclusions from large amounts of text. Because ultimately, the program doesn't care. It has 0 interest in what the output is, right? Okay, all it wants to know is what are the things that are most frequent? What are the combinations that are most frequent? And what can I do with them when it's done? So what we're going to do is we're going to take a look at that in a moment. And again, I'm going to show you how relatively quick this can be done. And I keep saying that, and I'm going to go ahead and do it. So, here you go. Hang on to that.
Hello.
I take my beer. Bear with me for one moment. All right, so the Rapidminer interface. And again, rapidminer.com. Go home, download it, it's free. Is it really free? No. Okay, but you will get to be able to process up to 10,000 rows of data free of charge with all the functionality. If you want to attack your 5 billion row database with it, then you pay. But in the short term, you have the ability to take finite amounts of data and crunch them. So in this case, what I've done, think this is bad when Bill Gates introduced Windows 98 to the summit, it blue screened on him during the presentation. So, okay, so this is not nearly that bad. When you go into Rapidminer, you're going to choose multiple pieces that go with it. And I apologize, but I'm going to have to explain them. That's not the best way to do this. When you open up a tool like this, or you open up R or use any tool similar to it, you're going to ingest into it a module that's going to allow for text mining. Rapidminer is real simple. It's called the text mining module. And it's going to give you an option to read a document. And the document scope that it can read is very expansive. So PDFs, Word docs, proprietary documents, including, some of the more extensive Adobe documents that, sometimes are read protected, which is cool because it has a tendency to go past that. So you're going to read multiple documents. And what you're going to do next is you're going to build a process document stream. That's that big piece in the middle. The only thing you need to remember is that you have to tokenize your documents. Okay? And what that basically means is you're telling the tool to take the 873,000 words that exist in Bram Stoker's Dracula and break them out into individual single tokens and count the frequency of each token based on a parameter that you've set. So in this case, I've told it to split tokens by anything that is a non-textual character, which would be the blank space between every word. And so basically what it's going to do is it's going to stream through those. It's going to identify a token for each group of characters between a non-textual character, and it's going to count their frequency. And at the end, it's going to give you an output that says, of all 850,000 words, murder, death, and blood, Bram Stoker's Dracula ranked towards the top. Okay? Now, sometimes that's not always great, because the appears a whole lot in most text. So you're also going to include in that, in addition to tokenizing, you are going to remove English standard words. A, the, and, or, else. And it's going to extract those out and really focus on the term, giving you the ability to create an output similar to what we saw. Ultimately, long story short, when you walk out the door, some of this sank in, some of it didn't, some of it doesn't matter, some of it will. But what you need to know is that the ability to do large-scale text mining is at your fingertips, it's accessible, and it's semi-free. It has tremendous implication in your business, and can be done quickly and in an automated fashion. Question? I'm sorry, I wanted to explain how to build that stream, but we're just home, and by the time I fix it, you'll all be ready for another drink.
You had mentioned mining Twitter accounts. In this case, you've got 3 speeches. How would you, in something like Rapidminer, grab multiple accounts of n size?
Right. So, if you've ever done any Twitter mining, you understand that you go out there as a developer account, they'll give you an API key, and you'll ingest that key, and it will allow you to extract information attached to a particular Twitter account. And it comes in multiple forms. The main form is that it comes in, you're going to go out, you're going to attach to CypherCon as the Twitter account, and it's going to bring back a series of identifiers that are attached to everybody who's following CypherCon. You're then going to take those individual identifiers and attach them, like we did those multiple documents. You're going to attach them. Now, the truth is, you're thinking to yourself, wait a second, 8,000 people follow Twitter. I'm not creating 8,000 of them. Okay, you don't have to. Okay, if anybody here has ever done any SQL work, SQL analytics services, SQL integration services, you understand the whole notion of a for loop when it comes to reading documents. Rapidminer has the same functionality. You'll point it to that list. What I do when I do that is I build out a database. I build out a database that has the updated accounts, I point Rapidminer at it, and I say, give me every bit of information that you have about every one of these people.
Thank you.
What's really cool is when it's all done, and you get the output. You know, Twitter is, I mean, can you imagine for a moment? Let's just think about this. If I took everybody at CypherCon, I went out and got all your tweets from the last 180 days and categorized them by theme and content. I mean, can you imagine? Imagine the themes you'd see. I mean, hacking would be a theme. Computer science would be a theme. Whatever themes might arise. You can develop a key profile for the type of individual that would attend a conference like CypherCon, turn that around into a marketing strategy, and target those people with ads about CypherCon. You ever wonder why you should friend this person in Facebook? It's because they're doing the exact same thing. Other questions? I'm sorry? Oh yeah, absolutely. I mean, particularly, both CypherCon are, if you join our programming, if you really want to, you know. The nice thing about R compared to Python is R is a vectorized computer program. It's made to do the same task against large banks of data. Okay, so geolocation and geomapping for particular bits of data is really simple in those. You can do it in Python too. But ultimately, yes, it has the same module that will allow you to bring in an indicator of geolocation, geospatial location, and then map it out in densities over whatever type of map you want. It's cool stuff. You know, if you're a SQL geek, you can actually do it in SQL as well. It's just, it requires you to write it in SQL. Other question? Yeah.
What about Office 365?
Yeah.
Can you interface with that? Do you need local teams?
Well, the only experience I've had is with local. It all depends on my understanding just from some of the jobs I've had in my lifetime. You know, they say millennials have 15 jobs in your lifetime. I'm on like number 8 now. So, in some prior jobs where corporations require a certain degree of archiving at a central source, you could use a cloud-based email provider with a local archiving solution as a way around it. But I've never actually interfaced with information stored in 365. Yeah. I'm sure that's something we'll ask me at some point, in which case I'll figure out today. Other questions? Hey guys, I really appreciate your time. Again, if you have any questions, I'm here tomorrow, I'm here today, I'm happy to answer them. You know, for those of you I've bored, I apologize. And for those of you that you know, have an interest in data mining, I'd be more than happy to, you know, put our heads together and see what questions you have. All right, thanks. Have a great day.